Hello, hola, welcome back. Today we're jumping into a key part of Linux, which is looking at processes and surfaces. Basically, every program you run in your system, whether it's your web browser or some background task, run as a process. Knowing how to handle these is a must for any Linux user or admin. By the end of these lessons, you will be able to see what's running in your system, keep an eye on processes, and take control of system services like a pro, like an expert. With that being said, let's get started. So now, what is a process? A process is simply a running program, and each process has a PID, which is process ID, which is a unique number assigned to the process at the time of creation, like a name tag, so the system can keep track of it. And then we have parent and child relations. Pretty much what that means is a process can create another process. So in better term, for example, if the terminal run a script, the terminal will be the parent, and then the script will be considered as the child process. And process can be in different states. We have running, the process is actively running and using the system CPU. We have sleeping, meaning the process is waiting for something to happen. We have stop or pause, which means the process can be paused by the system or a user. And then we have zombie process, which means the process finished running but still listed in the process table because the parent hasn't cleaned it up yet. Okay, so now process can either be executed in two different modes, and they are foreground and background. Foreground meaning the process is actively running in the terminal, you can see it, it's in front of you. And then we have background, which means the process is running silently in the background. So meaning if it's running in the background, it gets detached from the terminal, and you can use the terminal because the process is running in the background. So now that we have an idea what is a process and some of the state they can be in, and the mode that they can be executing. So now let's take a look at some process that are currently running in my system. So very basic command we can run is the ps command, which let us know the PID. The TTY is the terminal associated with the process. And then we have the time, and then we have CMD, which is the command. So when I first open the terminal, this process get created, and when I run the ps command, this one get created. But this is a very basic view because in our system we have way more processes running. So now let's move to the second one. We have ps, we have this one, ps aux. If we type ps aux, now we see we have a whole lot more running in our system. Let me scroll all the way to the top. Let's go all the way to the top. Okay, so we have a different column. We have the user column. Pretty much all of these are being run by root. We have the PID process, we have the CPU, we have the memory, we have the virtual memory size, and then we have the resident set size, and then we have the terminal that is associated with the process, which is TTY. And then we have start, time, and the command. So that's all I'm gonna go over for now. And then we have a different alternative to the ps aux command. We have an alternative one, which is ps-ef, which will show us way more details. Let's go up so we can see the difference between the two. Oops, I think I went way over here. So we have the user ID, the PID, the PPID, that is the process ID. We have the C, the S time, the terminal time, and the CID. Actually, the AUX show way more. But this one give us a little bit more details when it actually seems like I got it in reverse. My notes is a bit in reverse because the AUX show way more details. Does it? Let's see. Yeah, it show way more details versus the PS-EF. That's interesting. Okay, that is an alternative to the PS AUX, and then we have pgrep. Pgrep allow us to find PID by name. So let's put that to the test. Let me open Firefox. It's probably gonna create a process for that. Actually, no. Let's use Bash. Let's test it on Bash. Let's do pgrep bash. So there you go. So these are the two processes for Bash, and they are 5268 and 4960. If we go all the way to the top, I go too fast. We get the PID and then the process ID for that. That's what the pgrep does. It allows you to find the PID of a process by name. If you don't know the name and you don't know the PID because it's number, a lot of people have difficulty remember numbers. You can just use the pgrep with the name. It will give you the PID that is associated with that specific process. We also have the PS tree, which will show us the process in a tree, like just like the tree. Let me see, am I in? Yeah, just like the tree command, which show us our home directory in a tree. Like we have one the same way for the PS command. Let me clear this. Let's do PS tree by itself. So as you can see, it show everything in a tree, like, so it let us know what is running, what is coming from who. Oops, we have the systemd, which is should be at the top of the tree, and then we have everything that branch off from that. So we have the light DM, which is, and we go to the desktop, and then from that we have all of these. So that's what the PS tree does. But we also have PS tree with the PU, which will let us see the PID and the user that are associated with each. So we can do PS tree dash PU. So now if I go all the way at the top and the previous one here, this one was I run this without the dash PU. As you can see next to them there's the number, but with the PU it let us know the PID associated with each process. So that is one way you can view process, but be aware the PS is like a snippet of a point of time when you run it. It's not live, meaning every time you run the PS command, it doesn't actually give you, show it to you in real time. So keep that in mind when you run the PS command. So that's clear. But we do have a command that show you the process in real time. If you're doing things, you can see it, and that's where monitoring processes come in. We have two command we can run for that, which is the tab and then the tab. Both of them kind of do the same thing, but one is color coded, the other one is just blah. So let's do tab. This is live. because you can see things are moving, the numbers are changing. So the tab command I just run is here. Oops, let me highlight it again. The user that run it was, well, it doesn't stick, but was me. Oops. Teddy, the process is 5466. We have the CPU usage, we have the memory usage of it, so it's not really using a lot. So this is what the tab does. It's live, so you can view things live with this. So if I press Q, I exit. So now let's take a look at the htap. So htap is not installed. Let me see if I can quickly install it. Sudo apt install htap. Hopefully it doesn't take a long time. Okay, come on. Okay, perfect. So let's run htap. So as you can see, this is a little bit more nicer. I mean, it's more packed. Everything is on top of each other, but it's color coded. The same thing. We got the htap command that I run, Teddy, the PID. We have the virtual size, the memory size, the CPU, and the command that we use. And then I know we have different headers, but the most important one are the PID, the user that created, the CPU, the memory usage, the time, and the command header. Those are the most common one that you should care the most about. And then we have at the bottom, we have a help menu. You can press F1. Oops. You can press F1 for help. Oops. Oh, you don't press it. You have to click on it. Oops. So when you click on them, it show us what do you want to see, what do you don't want to see. You can kill a process. Let me press. Let's exit out. So the htap is a little bit more nicer because you do have this bottom help key, I should say, that let you know that you can view the tree size, list, sort by, nice, kill. You can kill a process right there. So let me exit out. Let's run the tab again. You see the tab didn't have the bottom help menu in it though, and it's very basic. So these are the two commands you can use to view processes running in your system live while you're currently doing things happening. I haven't get to it yet. I did get to it yet. What am I saying? So these are the state that I mentioned: the running, the sleeping, stop, and zombie. These are like the state that the process can be in, which is these 4 ones. So I have 2 running processes right now, 286 sleeping, 0 stop, and 0 zombies. So let's keep moving. Okay, well, so understanding htap, let's go back to it again. Seems like I'm all over the place. So the tab bar, which is the CPU swap usage, color coded. We have the middle pane, which is the list of processes with life update, and then we have the bottom function key. I should say function key. We have the bottom bar, which is the function key for action, which I show you guys over here with the blue highlight. And these are the action key you can not really press, clicked on, because pressing them doesn't do anything. I mean, they can do something. Oops. Sickle. Wait, let me do that again. So this is all the signal you can send to kill a process. Actually, guys, these I have not done them beforehand, because these I actually do them while I'm filming these. Even though I know how to use Linux, a lot of these I'm only going through them for the sake of this video I'm creating. So Not that I know everything about Linux, because at the same time I'm also studying for my Linux Plus. So these videos are a way for me to learn and to also share that with you guys. So that's why sometimes I might press something and doesn't know what it does, because this is the first time I'm actually viewing these, because this is my way of studying for the Linux Plus, which I should be taking sometime at the end of the year. So this is the function key, which we can use for different function. So let's exit out by pressing the Q. The Q key. Let me clear the screen and keep it moving. So before I did go over what is a foreground and what is a background. So now let's put that to let's do a demo for that. I'm gonna use the sleep command. I'm gonna run the sleep command for 100 seconds, and I'm gonna send it to the background. So if I do sleep and then I send it to the, I can send it to the background. So it let us know we have one background process, and then that's the PID. So if I type jobs, now that we see we have one job, which is our job that is running in the background. This would run for 100 seconds, and then we can bring it to the front by do the FG. We can do the % sign with the number, which is 1. And now, so the thing is, when you run a job process in the foreground, the terminal, you will not be able to use the terminal while that is actively running, but you can if you send it into the background. So let me cancel out by pressing Ctrl C. Let me do that again. So if I do sleep 100, even if I type things, I press enter, nothing is happening because the terminal is actively busy with the sleep command. So if I close this out and then I do sleep 100 again, and then I use that symbol, the end symbol, it will send it to the background, which means now I can use the terminal just like regular, meaning I can use it. So keep that in mind. If you send it to the background, you can use the terminal. If you keep it in the foreground, you will not be able to use the terminal. So just keep that in mind. So this is how you send up. So I use the sleep 100, and this is the symbol you use to send anything you want in the background. So if you want anything, let me see, what can I run? Let's do PS. As you can see, this is running. I mean, this was not a good example. What can I use that will actually be a good example? I don't know. Well, the sleep command is the best one. I wanted to use something else, but the sleep command is the best one to use per se. Well, and then let me actually to bring it back, you use the command BG with the %1. The 1 can be anything. The 1 is being used here because when you first creating it, it will give it 1, but the more you create, the 1 will be a different number. So whichever process you want to bring to the background or to the foreground, you just use that number with the %sign. So that's how you send something to the background, and then you bring it back to the front. Let's clear the screen. Oops, let me see, is this still running? Jobs. Okay, it's finished running. So that's why when I run jobs, it's no longer there because the sleep command was being run for 100 seconds. So now let's move to killing processes and process. So let me do PS AUX. Now let me open Firefox. That will create a process for us. Okay, while that's running, we don't actually need this. I'm gonna minimize it. Oh, that was a bad idea. I forgot. PS is a snippet. I should have used stop. Let's use stop. We should have Firefox. There you go. We have a process for Firefox, and it is 5695. So now let's get to killing processes. So if I want to kill this process, where is it? Where did it go? Where did Firefox go? Oh, there it is, 5695. So we can kill that actually. We can close that out. We can do kill all. Nope, not kill all. I'm getting ahead of myself. Let's do kill. And the process for it was 5695. 5695. Boop. Now, if you look at the bottom here where my mouse is doing the circle, as you can see, Firefox is no longer there because I kill it. So I kill it. That is one way to kill a process, but we have different way to kill processes. This is the most basic one. You just kill the process ID and then boom. But we do have option we can use. We can use the -9, which will forcefully kill a process. Well, is there something I can open again? Let's open chess, which I love to play chess. Let's open chess, and then we're gonna do tab. That will give us a process for chess. And if I can see where it is, maybe it's not gonna be chess. Not sure what is the name is gonna be for that. Oh, there it is, GOM chess. Oh, okay, so the process is 5996, I believe. Oops, it's gone. Okay, well, it's there, even though I can see it, but I can look for it. So one way to look for it is to use the pgrep. Let's quit pgrep. So there you go, pgrep. Now I'm putting some of the command that I showed earlier to hunt processes down. So we have two of them, 5986. Let's forcefully kill that. I mean, using the -9 in this situation is not really useful because chess is a basic program. It's not stuck. Nothing is stopping it from closing out. So, but using it doesn't really do anything, just to forcefully killing it. But we can use it anyway. So let's do 5986. Boop. If you look at the bottom again, chess is not there. So this is one way to kill process. You can either kill it gently with the process ID with the kill command, or we can use the -9, which will forcefully kill it. So these are some of the way you can kill a process, which is sig9, politely request to terminate the process, sig9 to forcefully kill it, and then we have the sig1, sig up, which is a hung up process. We start or terminate the process. But we have way more than this. These are the most popular one. But if I type htype again, we have a whole list. Htype, and then if I click on the kill F9, this is all the list. Send signal. So we have the 9, which is the sig kill. We have the 15, and then we have the 1, which is the sig up. So if you want to know the full list, there it is. So we have a whole lot of send signal for getting rid of process. So I just wanted to show you guys that. So when you type the htype command and then you press F9 or you click the kill, it will bring the list of the send signal. We can also kill process by name. Let me open Firefox again. Let me close out of here. Let me minimize this. Oops. Yeah, okay. So let's do pgrep Firefox. So the process for Firefox is 6032. So we can do pkill the name Firefox. Poof. Again, if you look at the task menu, the Firefox logo is no longer there because we got rid of it. And then we can also use the same send signal with the pkill to forcefully kill it. We can use the F, match against the full command line, not just the process name, which I would recommend because you have to know the whole name. So we can use username to kill only process owned by a specific user. So I don't know why multiple user would be running a process into this under the same username, but that is something you can use. I guess if you want to kill all the process owned by Teddy or root, I guess you can use that. Well, then we have kill all process. That will kill anything associated with the process. So we also have the same send signal, the 9, to forcefully kill it instead of the seek term, which is the politely request to terminate the process. We can also use the -u for the kill only process owned by a specific user, and then we have the -r where we'll treat it as a regular expression. So for example, and let's boot up Firefox again. Can I Firefox? So there you go. I run. So now I'm running Firefox and I send it to the background. So that's why I'm able to use the terminal, putting some of this comment to use live in front of you guys. So that's what happened. So when you type Firefox in the N symbol, it let you know the process associated with the the ID associated with the process, which is 6335. So now if I do htop and we look for Firefox, I shouldn't use Firefox. I shouldn't use. Okay, so as you can see, right, Firefox also has a -ESR, but this is also not a good example to use because I don't need to write the whole command to terminate it. But that's what never press go. But that's what the -r does. It will treat the input you provided as a regular expression. What I mean by that is, so let's do kill all, and then I do -r. The -r will let me treat whatever I input as a regular expression, which means, as you guys saw, that Firefox also has a -ESR. So if the whole name was required for me to kill the process and I didn't know the -SR, I could do quotation mark Firefox, and then I can do the dash and then the star sign, meaning the star is wildcard, meaning you can use it to hunt down file name and anything. Well, mostly file name, directory, if you don't know the whole thing. So for example, if you don't know the full name, so the star can be anywhere. So for example, since the star is at the end, meaning it's going to look for anything with Firefox with dash, and then it's gonna ignore the rest. So anything that starts with Firefox dash is gonna kill that. So if the star was at the beginning, it will have ignored anything at the beginning, and anything that end with Firefox, same thing. If I put the Firefox the front and the back, anything that has Firefox in it will get killed. So for this one, if I do this, it should be able to kill the Firefox command in the process. Actually, it did kill it, but it also give us a channel error because the process was being run in the background. But if you do look at the bottom, Firefox is no longer there. It's gone. So because it was running in the background, so that's why we get the exiting due to channel error. So that's what the OR allow us to do. So we can hunt down for things that even if we know half of it, not the full name. So you can, I know this is not about wildcard. That's what we call the store. It's called a wildcard. So for example, I'm just gonna give a little breakdown of how to use the wildcard. Let's say I'm just gonna still keep using the Firefox, right? So let me do the same thing. I do star Firefox. So what will happen here? The star is letting out the system know to ignore anything that come before the Firefox and focusing on anything that end with Firefox. That's what the star at the start mean. If I put the star at the end of anything, so Firefox like this will look for anything that begin with Firefox and ignore whatever that come after it. So if I do that, same thing, look for anything with Firefox, that ignore the rest. If I do store here, it will look for anything that has Firefox in it. Doesn't matter, anything with Firefox, it will hunt it down. So now we can get very specific. Let's say we know that we have a file that has 2 in it. So let's say we have a file called let's say we have file 1.txt. So what we can do is, let's say we can take the 1, we can put the star in place of it. So what will happen is so it will look for anything with file, anything, and then look for anything. So this can be anything. It will look for if it's file 1, file 2, file 3, all of these will show up. Let's say we what else we can do with this I think these are the most common one, I think, in my opinion, because you can really get more granular with this little asterisk sign. What else we can do? We can look for 2 letters as well. We can do stuff like this. That should also work. But the one that I show you guys, like I said, I'm not an expert in wildcard. The one that I show you guys are pretty much can get the job done to look for things if you don't know the full name of it. So that is a little bit of background in how to use wildcard. So let's keep moving to process priority. So nice is a command we can use to set priority to processes when they start, and we can also use renice to change priority of an existing process. So let me clear the screen. So how the number work is -20 is the highest priority, meaning they will get the most CPU or RAM or whatever resource that they need, and then 20 is the lowest. So this will be -1 to -20, and then this will be 1 to 19. So these are lowest priority. They're okay, but this is the highest priority. So how does this work? Let's use the sleep command again to put that into use. So if I do nice n, I can give it a priority of 10, and then the command for 500 seconds. Oops, I forgot. I'm running it to the foreground. The terminal will be busy for 500 seconds. But let me cancel out of this. Let me send it to the background so I can have views of that. So let's do the same thing again. And 10 sleep, and then let's send it to the background so we can use the H tab to see what's taking place. Oops, I put nice. Let's put nice. Okay, perfect. Let's do H tab. I don't know if you can I don't know if you can use edge stuff is running, because let me see, let's go all the way at the bottom. So there you go, the sleep command is currently running at the bottom. Sleep 500, we have a process ID, and then we do have a the nice column, which is the NI, which is the priority of 10. So now this is running because it's 500 seconds. I don't think it's gonna get done anytime soon. So now let's change the priority to something else. Let's do nice, and then let's give it a priority of 5, which is on the highest priority. If I'm being honest, I forgot the process ID, but I think it's 6626. 6626, hopefully that's correct. Well, oh, only sudo can change priority, so let's do sudo. So now we have a message that let us know the process 6626, which is the nice command which is the sleep command, process ID old priority was 10, now the new priority is 5. And then we can also view it if we do ps-o. The -o let us choose which column we want to see, and we can do we want to view the PID, the nice, and then the command, and then the process number 6626. Oops. So there you go. This is the command that was one. Sleep, the nice, the priority is -5, which is on the highest priority, and then the process ID, which is the 6626. So we can use the nice and the nice to change priority of processes, because when you change the priority, that's when they get more resource. So highest priority get more resource, more CPU, more RAM, etc., etc. If it's on the lowest priority, it's alright. It's being treated just like a regular process. So let's do htap again, so we can see, as you can see, most of this process have a default nice, which is 0. Pretty much all of them have oops, we do have one that is on the high priority. Well, it's okay, it's not really high, but it's on the lowest priority, which is 19, which is this command. And then the sleep command, which I'm about to kill right now. Let's kill it by pressing F9. Now let's choose which command to use to kill it. Let's use this one, ckill. Poof. Now the sleep command is no longer exists. No, oops, let me press Q so I don't mess things up. So now if I search for it again, it's not gonna show me anything because that process no longer exists because I kill it. So this is one way we can change priority of a process, and from the get-go. So we can use the nice to give it priority at the moment the process is going to start, and then we can use the nice to give it a different priority from the number that it started with, and then we can use the PS with the -o to choose which column that we want to view. So that's one way to keep things nice and viewable if you want just to view one process. So now let's move to system services. Now we were looking at processes, now we're gonna take a look at services, which are also known as demons. Not really sure how to pronounce that, but it's there for you guys to read. So systemctl is a command line tool used to manage services on system using systemd. Systemd is the system service manager for Linux. So system can either systemctl can either start, stop, and enable, disable, and check the status of services. I don't know why I skipped that line and I jump over here, but that's pretty much it. So systemctl is the command line tools that we use to manage the service, and then with systemctl we can start, stop, enable, disable, and check the status of service. And then the systemd is the system service manager for Linux. We also have journalctl, which used to view logs related to services. It can show logs for specific service, boot session, or even live updates while things are actually happening in the system. So what is a unit? Unit is something that you will see. So you guys need to know what is that. So if we scroll down here, there's a command where you can type systemctl list units and then the type, which is service. So we also need to know what is a unit. So a unit in systemd, it's pretty much a configuration file. So in systemd, everything it manages is called a unit. A unit is just a configuration file that tells the system how to manage resource. So for example, there are different, for example, that SSH service has a configuration file. That's how you can change certain configuration on how SSH should run, etc., etc. So we have different type of unit in Linux. We have the service unit. SSH will be one of them. We have sockets, which allow a service to start only when requested. And then we have target services, which are a group of units, which is a group of configuration file. And then we have mount, device, etc. unit, which, you know, we have a mount file, which I think located in tab. I think that's where mount file is. Yes, I'm not gonna get into mount yet because there will be a video dedicated to mount, how to create mount into Linux, permanent, persistent mount, etc. So what is a service unit file? A service unit file is a file that defines how a service should behave. So let's go and take a look at where they are located. They are located in etc systemd and then system. So inside of here, as you can see, we have a bunch of that services. We have a smart service, we have socket, we have an SSHD services. Let's quickly take a look at that one. Let's do cat SSHD service. So when we click on it, you can see is a text file that let us know how that the SSHD service should behave. So this is the first time I'm looking at this file, so I'm not really sure what's taking place. So we have a description, which is a OpenBSD secure shell server, the documentation, which would be the main SSD, which is, oh, I need to do a video about the main page, because the main page is very helpful when it comes to finding useful information. The service, this is what let the service know how to behave. Okay, well, the video is not about this, so let's exit out. You guys can take a look at this on your own time and dig a little bit more onto what it's doing. So let's go back. So that's what a unit is. So in case you guys see it, you guys wondering what is that. So a unit is pretty much a configuration file that tells the system how to manage resource. So now let's take a look. I think I have SSH in my system, so we can do systemctl status. That will let me know the status of SSH. If it should be running, I think, but we will find out. SSH. So it let me know the status of SSH. As you can see, it's actively running. It's enabled. It's enabled. So we can use systemctl to check status. To stop, where is this VM? Is this VM? Okay, I can stop SSH because I don't think anything is using it, so it's not going to mess up anything if I stop it. So let's do systemctl. I can do stop. I mean, I'm not gonna do start because it's already the service is running, so that obviously mean the start command was used to start it. But I can stop it. Want me to put my root credential. So it did not give us any output, but if we do the status again, it will let us know it is inactive, dead. And then we can do a restart to restart it. Restart SSH. Want me to put my sudo creds. No output. Let's check out the status again. It's running. It is running again. So that is one way we can view the status of services running. We can do start, we can stop, we start, enable to start it at boot, disable, and then we can even reload. Do I have nginx in this system? Let's do dpkg -l grab I don't even know if I have that installed, but okay, maybe not. Do I have Apache? Did I have Apache in the system? Okay, I do have Apache, so we can try that on Apache. We have Apache 2, which is the top one. We can do reload. We can check the status of that. We can do system. We can do systemctl status Apache 2. So Apache 2 is running. I can do a reload. That's not gonna do anything to us because this is just for lab. We can do a reload to reload the whole service. Ask me for my creds again. So it reload. I mean, it doesn't give us any output, but I can do status. It's running. Everything seemed to be good. So we can use systemctl to do that, to start, status, check, stop, all those things. And then now we can do, that's why I put the service unit and what is a unit into this note section, because we do have this systemctl list unit. So you guys know, could know what I'm talking about when I mention the systemctl list unit command. We can do list unit type. We're looking for service. So this is all the dot services. Like I mentioned before, we do have different type of unit. Service is one of them, and that's what we're hunting for. So we're looking, so all of these should have a dot service at the end, and we can also do the same thing for socket. Is it sockets or socket? Okay, no, it's socket maybe. So we do have a couple for socket. So to view different type of unit, we can use that to view them. We do have journalctl, which let us view log for that specific service. So since did I restart SSH? I'm not sure if I restarted, but that should be part of the log. Let me do journalctl -u/ssh. Did I type that correct? Journal, or I make a mistake. I forgot the or. So the journal, let's see. You're currently not seeing message from other user in the system. User in the group admin systemd journal can see all message. Press Q to turn off this notice. Okay, let me see. Maybe I'm not sudo. Okay, it requires sudo to view logs. So as you can see in the log section, we did start SSH, we did stop it, we did restart it, So that is these all the log that is related to SSH. There's not going to be a lot of log because I don't use this system for nothing but these videos I'm creating. So it's the same thing. If I do the same thing for Apache 2, it's the same thing. You know, I start Apache. That's pretty much all this thing. I don't think I stop it or we started it. So that's why you only, I mean, it did get stopped here. I did stop Apache. No, let's see. Oh, that was all in September 27. These are all log file, actually. Oh, we have more. What am I saying? We do have more. Let me press enter to go all the way at the. You know what? Let's do this, but let's wipe it to less. No, what am I doing? Not less, tell. I need to view tell. Let's do tell. So tell will show us the last 10 log into from the log. So that's what the tell does. It will show us the last 10. So this is the last 10 message from the log file for the SSH. As you can see, the date is October 5th, which is today, 8/19, which is today, and then the service was reloaded. Apache 2 service. So this is one way you guys can view logs. Let's say you start SSH, you got an error message, and then you want to know what's going on. You can quickly use the journalctl to view log for that particular service if you want to. If you just type the journalctl by itself, it will show you log for everything, but that would be too much. But yeah, for legacy system, you guys, we can also use service. I don't know if that will work. Service Apache 2 status. Oh, I guess service. This is a new system, so service is for legacy system, so it might not work unless I'm typing it incorrect. Service. So service is in there, so it must be me who's not typing it correct. Well, for better use, let's type service status all. And let's do service status all. Well, maybe the main comment is, oh, is it because I'm not running a sudo? Oh, oops, that was not a good idea. Let's not do all. Let's do Apache 2 status. So service can also do the same thing as systemctl, but this mostly get used for legacy system, because systemctl is for more modern, the US system. So, and by the way, all of this comment I'm showing you will work in Red Hat and CentOS, because they all use systemd. So this will do the same thing. So for a quick demo into well, if I quickly go to my RHEL system and I go here, I don't know if I have SSH installed, but if we do systemctl status SSH, so SSH is not installed in here. So let's see if we have Apache. Apache is not installed also. Is it because I don't have sudo? Maybe it's because I'm not running as sudo. Let's see, sudo. Okay, so let's quickly do something. Sudo dpkg-l. No, that's not dpkg though. It should be Yeah, red hat is a little bit tricky with that thing. Nope, that will bring me too many things. Apache 2. So there's no Apache into the system. SSH. So SSH is indeed in the system, but I couldn't view it. Oh, it required the D. Oh well. So I guess that's the difference. So it requires for you to put the SSD at the end. So as you can see, you can still use the same thing with the where is it? Where is it at? Over here. You can so it will use systemctl to view. I guess the name might be different, but it does the same thing. Okay, so let's go back. Let's press Q to exit. Yep, so modern system use systemctl, but legacy system use the service. So now we do have a couple of commands we can use with systemctl. We can use list unit file type. Service, I already went over what is happening with this command, but we can also check to see if SSH will run at boot. So we can do let's do clear. We can do systemctl is enable SSH. So this let me know that SSH, every time I boot up the system, SSH would automatically start with it. So we do have other output you can see. You can see enable, disable, or mask. So the mask will stop the service from running, from automatically start at boot. So that's what it does. So I'm not gonna run the other command, just go over them. So systemctl is active, will let me know if the service is currently active or running, but you guys did see that it is running. This is how to show this is one way to show if a service will start at boot, or if not, or the state of the service. Let me quickly go over this list. Unit file type service. Did I type that correct? So this let us know which system, the state of each system. Let me so a lot of these are disabled to begin with, but they are enabled. Apache 2 is enabled. If I did go, let me press space to go at the bottom. Where's SSH? Where is so SSH service? Oops, nope, that's not it. SSH is enabled. Both enable and the preset is enabled. So this let us know the state of the service, the unit file in our system. We have an alias util service, which is mass. Until it is on mass, it's never gonna start at boot up. So that's where we get our next section 9. So we can view system.crash, but I don't think we're gonna have any, because this system systemctl-fail. Yeah, nothing is gonna list it, because I don't use this system for anything. So but we can mask certain system if we don't want them to start. So prevent service from starting, we can use the mask for that. So mask the service by linking it to dev null. Dev null is a place we send stuff that we don't need, pretty much. So service cannot start manually or at boot until on mask. So if we mask it, it's not gonna boot. It's not gonna start at boot until we unmask it. So we can use the mask command to prevent it from starting, and then we can unmask it to enable it to start at boot. So that's pretty much how to view fail command, block a service from starting at boot and unblock it, and then we can view the state of a service by doing, is it enabled, is it active. You guys can get more information by running the main page, which I'm gonna do a video on the main page, ctl. So this has a lot of information. So unit active, this is some of them: active, inactive, fail. So there's a lot of useful information, but you just gotta know what you're looking for, how to search for certain things to be able to put it into its full use. So let me close. Wait, let me run this again. I think if I press that, let me see. Let's go. The service which were masked, not found, or otherwise fail. Mass. Let me see. Yeah, so I need to do a video about the main page, because there are a lot of information that you can find by reading the main page, but at the same time there is a lot of information in here. Okay, so now we arrive at the end of the video. Some of these are about log and how to troubleshoot. So journalctl, I already went what is the purpose of that. It let us know log for certain type of service. So if we do journalctl, the name ctl ssh, so there's nothing. I mean, I don't have the sudo, but yes. So if I do sudo, so all of these are in regard to ssh, but we can do journalctl with the dash. We can do that with the xe. Let me bring this so you guys can read what it's saying. So we can do I don't have to keep typing back and forth. Let's do xe. So with the xe, it just show up with more details, color coded, so you guys can have a little bit more flavor, I guess. Let's press. Well, I guess that's it. There's no more. Yep, it let us know user, the terminal, the home directory, and all the good stuff. So that's the difference between running the dash xe. So the X is for the detail and the E is for event that took place. We can also do the same thing we can use the flag since to show us things that happened in the last 2 hours. We can also do let me bring that back so you guys can read what it says. Let's do the same thing for this. So we can do the dash F for live log. Nothing is gonna happen, well, because nothing is taking place. So we can do journal ctl u for the name of the service, dash F. Oh, I keep forgetting sudo. Oops, I keep forgetting sudo. So as you can see, if I press enter space, nothing is happening, right? So let me put this to use. I'm gonna open can I do a split column? This terminal doesn't have a split column. Oh my, it doesn't have split column. Okay, well, let me quickly open a new. Let me not open let me close this. Can I close this? Of course I can. Right here. Actually, I need to open a new terminal so you guys can see what's gonna happen. Let me do systemctl reload ssh. As you can see, we have some activities on that side. I don't know if you guys are paying attention. Some stuff happened on that side. So it let us know, receive the SIG up. we started, we load SSH service and then the port it's listening to. So let's do that again. Let's do stop. But I'm tired of do this. Let me just do sudo actually let's do sudo s. Now let's do systemctl stop SSH. So as you can see, most stuff is happening because this is live. That's what the -f does. It shows us a live log. So let me exit out. Actually, let me run this. Let me do start SSH. Start SSH. Let me check the status. Make sure everything is working. Okay. So now let me exit out. Okay, perfect. So this is what the -f does, and then this journal -b will be for logs that are happening at boot time. So let me do -b. So these are logs that happen when I first boot up the virtual machine. I have no idea what's happening here, but that's what's happening to show you logs at boot time. I'm running VMware. That's pretty much it. Okay, that's it. And logs are located at var -log. So you can also view these manually without so if I do cd-var ls, so here you can view all type of logs, Apache log, stuff that you download into the system, VMware, all of these are VMware network app. So this is where some of the log located, which is and then we can do ls-a. Oops. So you do have journal for logs that are related to that. We have boot log, the same thing that you view with the -b. You can view them in these. Yep. So that's where logs are located, which is in the -var -log. And I already went over these signal, what they do. You know, graceful termination, forceful termination, pause process, and resume. So these are things that I went over. I'm just gonna go over them. Regular PS will show us just the basic PS, does the basic process in our system. That's it. With the AUX, we'll show you more details, more explanation on the process, just like the EF, which also show us some details, but not as much as the PS. Yep, this, so not as much. So let me see something. Let me make this bigger for a second. So that's what's happening. One thing I didn't go over while I'm here, let me just quickly go over that, because you guys might wondering what all these -SS means. Let me quickly go over these, because you know, in case you guys wondering what those symbols are, and you guys should know what they are. So let's go. These are in regard to the state of the process. So some of the common one that you will see, I have no zombie process here. There's no zombie process, but if there was a zombie process, you will see the Z, the capital Z letter here. The R, if you see an R here, that's usually for a running process, but a lot of these are not running because you see 0 for everything. You do have the S process. You do see a lot of them. All of these are sleeping. We have the D, which is for uninterruptible sleep, which probably means waiting for input or output, which you don't see here also. Most of my process in this virtual machine are sleeping. There's no zombie process here. Oh, we do have a running process, which is the SSH is running, the PS is running. These are running process. You do have a T. There's no T here, which means stop, which stands for stop. And then we have I, which is for idle. And then we do have these long one. I can quickly go over them. SS mean sleeping in the session leader. And we have just the S is meaning sleeping. We do have the I with the less than symbol, which means it's idle and it's high priority. That's what that is. And then we do have the SSL, which means it's sleeping, and then it's a session leader, and then the L meaning the page is locked. And then we do have the SLSL, which means it's sleeping, it's a multi-thread, and the session leader and page lock. So these are what they mean. Oh, we do have the plus sound, not the symbol, which stands for foreground process. These are running in the foreground. SOG is definitely running. That gotta be running. So it's in the foreground. That's what the dash, not dash, the plus mean. The N is low priority. What else? What else do we have? I think that's it. I don't want to kill you guys with too much information, but these are what the state of the process are. So if you're looking at this, you want to know what they are. So that's what they mean. So you can know what state the process is currently in. Let's go back here. So you guys know about the tab, tab command, jobs, how to view background job, how to bring a job to the foreground, how to background the job, how to kill a process, how to change a process priority with the nice, to give a process priority with the nice, or to give it a new priority with the nice process. And then we move to service management. You know, you guys should know I went over all of these with you guys. And then at the end is a little challenge for you guys. Start a background job that sleep for 300 seconds, check its PA process ID and bring it back to the foreground, and then change its priority to 10 to minus 10, which is on the highest side of things, because minus numbers mean they are on the highest priority. And then last but not least, well, this is last actually, and then kill it using its PID, not by name. Kill it with its PID. So that's all I have for you guys today. I hope you guys enjoyed this. Until next time, adios and au revoir.